Hi everyone. In this study, we propose a new blur-based privacy preservation model, named DartBlur, by taking into account the actual accessibility of the model, review convenience, and detection artifact suppression simultaneously. DartBlur model is associated with 4 novel training objectives that each directly addresses the desired properties. We also design an adversarial training strategy. With a second-order optimization for model training, we demonstrate that DartBlur can effectively protect personal privacy while suppressing detection artifacts on various benchmarks. Hi, this is the short video presentation of DartBlur, privacy preservation with detection artifact suppression. We propose a new blur-based privacy preservation model by taking into account the actual accessibility of the model, review convenience, and detection artifact suppression simultaneously. Face anonymization methods are used to protect private information and real-world data. Blur-based methods are already preferred in almost public datasets, which containing face information, for example, ImageNet and Ego4D. Images with blurred faces produce artifacts for object detection tasks and affect the performance of the face detector. Specifically, the detectors trained on the blurred face images cannot be generalized to clean faces, and vice versa. We performed an experimental validation of this. First, we train the face detector RetinaFOSS on the dataset of blurred faces, and use it to detect faces on the original images. On the other hand, we train RetinaFOSS on the original dataset, and evaluate its detection results on the blurred dataset. 2 detectors are unable to complete the detection task in both experiments. It is clear from the visualization and evaluation that both Gaussian blur and pixelation methods produce artificial artifacts on the face detector. The above concerns motivate us to rethink and design a novel blur-based privacy protection paradigm, with the following goals. 1. Accessibility. The method should work well, without relying on the quality of other pre-trained models, such as landmark detection. 2. Review convenience. One can quickly determine whether or not identifiable human information is successfully concealed during an ethical review. 3. Detection artifact suppression. The blur function should avoid introducing much training artifacts to the detector, and specifically, we desire the following properties for detection artifact suppression, as illustrated in figure. DartBlur is a learnable UNet model that is fed with Gaussian blurred images and face bounding boxes as input, and outputs detection artifact suppressed blurred images, without relying on other pre-trained models, like landmark detection. We propose 4 training objectives, each specifically addressing the mentioned concerns above, and the implementation resorts to an adversarial training strategy, with a second-order optimization pipeline. Optimizing these objectives is not straightforward, especially, G does not appear explicitly in L subcycle. To overcome the difficulties, we develop an adversarial training strategy with a second-order optimization pipeline, through unrolled first-order optimization loops. The intuition is that model F sub G is trained with the blurred image GXB, and the ground truth bounding box B, so we contract a high-order influence from G to F sub G to L subcycle, and thus backward grading from L subcycle to G. We evaluated the effectiveness of detection artifact suppression, and the results are reported in the first row block of table. DartBlur obtained the best results on all 3 fidelity metrics, indicating that detection artifacts have been suppressed. To test whether the DartBlur model trained on wider face dataset could generalize to other datasets, we involved the FDDB and Crowderman datasets. Experimental results are reported in the last 2 row blocks of table. The conclusion remained the same with wider face. In other words, DartBlur obtained the best results among all baseline methods, indicating that the model could be well generalized across different datasets and architectures for detection. We conducted experiments to test whether private information can be recovered from DartBlur. We trained an in-domain UNet model to reconstruct the original, clean images from DartBlur images on wider face. The results demonstrate that the erased privacy information cannot be trivially restored. These are examples of front, side, and minority faces, anonymized with DartBlur. We conducted a human evaluation to assess the effectiveness of privacy protection. We displayed 20 randomly chosen original images and their corresponding Gaussian blur and DartBlur images to 95 individuals and asked them to judge whether facial characteristic information is completely protected. An example of 20 questions is shown in figure, and table summarizes the results and shows that DartBlur has better privacy protection effectiveness. Thanks.